So we're going to talk a little bit about generics. Has anybody here worked with generics in some other programming languages? Okay. All right. Okay. So the bad news is, there's no real plan right now to get those implemented in PHP. The good news is I'm trying to get people excited about them. So let's start. If you want to get the slides, right here. Okay, so in 2016, Ben Scholzen and Rasmus Schultz made an RFC for generics. So it's been around for a while. It has not yet been voted on, so at least it still has a shot, right? So in this presentation, before diving into generics, we're going to look a little bit at what are types, dive into a little bit of type theory. We're going to look at what it means to check types, type checking. Then we're going to explore PHP's type system and kind of see what its characteristics are. And then we're going to identify kind of what's missing in our current type system and where generics might fit into this picture. And then finally, we'll look at a brief history of generics in some other languages. Okay? So the very first thing we need to ask ourselves is, what are types? So if you have a variable like this, animal equals new duck, it means animal is of type duck. Now, it is important to distinguish what kind of types there are. First, we're going to look at what it means to have a weak versus a strong type. So a weak type, such as in PHP, you can define a variable and assign an integer value to it. And then later on, you can change the value of that variable to something other than an integer, like a string, and PHP is cool with that, right? Absolutely no problem. Now, if you're trying to do that in Java, Java's going to be like, look, buddy, no, don't do that, right? So Java recently introduced kind of implicit typing. So if you do var, you can use var now in Java. Yeah, it's full circle. Foo equals I am a string. It's the same thing behind the scenes. It translates it to string foo equals I am a string. Okay, so it's implicit, but it's still a strong type. It won't let you assign an integer to it afterward. Okay, so that's weak versus strong. All right, now let's look at dynamic versus static. So static means your type is validated at compile time, right? Type mismatches are actually syntax error, as they should be in my opinion. But and dynamic validation means it's validated at runtime. Okay, so that was dynamic versus static. Now let's look at implicit versus explicit. So an example of implicit is duck equals new duck. So here I have an implicit duck, right? I did not, when I did the duck variable name, I did not put something that says, hey, I am of type duck, right? I just do an implicit declaration like that, okay? Now, PHP 7.4 is going to give us explicit types on properties. Yes.
Really?
Yes. Yeah.
Okay.
Yeah. We believe. So now this is what it will look like. Private duck duck. So we will have explicit types on properties.
Some holy shit will explode then.
Yep. And for good reasons.
Yes.
All right. So another example of explicit usage is if you have a method called feedDuck, and you say in the argument, I explicitly expect a duck. Okay? So that's another way of doing explicit type in a parameter. So I know that I will only feed a duck, right? PHP is not going to let me feed anything other than a duck in this example. Now I could have an implicit duck, public function feed duck, and here I don't specify the explicit type, and in which case I hope that I will only feed a duck, right? Plug and pray. So I made a little program to illustrate these things in PHP. So I made a function with an integer as my argument. Okay, and then the very first thing I do is I take my argument and I say, oh, I am now a string, right? So what used to be an integer, here I am now transforming it into a string. And then I echo my argument. PHP is totally cool with that. Now, so then in my execute method, I call show with an integer, and that's fine. Then it'll show then it'll show I am now a string and then the number, right? But now if I call show, this should throw an exception. I'm expecting an integer here, right? So I'm passing it a string. So this will actually throw an exception at runtime, not at compile time. And this is where this illustrates the compile time checking versus the runtime checking. PHP does runtime checking of types. So basically, if I comment out this execute method call, function call here, right, and I go PHP on this PHP file, it's not going to output anything, but PHP is not going to complain about anything, right? Even though in here I'm doing something that's illegal, because this code is not executing, PHP is not going to complain, okay? Because it checks at runtime. Now, if I do put this execute method in there, right, then I do get a runtime exception, okay? So this little example kind of illustrates the type system in PHP. Okay? Yep.
Without string types, it wouldn't even explode. I think it would just go with
Yeah.
zero.
So if you don't put that and you feed it that, it's not going to throw an exception. I forgot what it does, but yeah. Like, woo! No, it'll be like, I don't know. Yeah. So, now let's look at type checking. I want to look at the workflow in a statically typed language. Has anybody here worked with Golang, Java? Yeah. All right. So if you work in Java or Go, first you're going to write some code. You're going to compile it. Then you're going to deploy it. That step may be nothing. And then you're going to run it. And your type checking is going to happen at compile time. Yes. Now, the cool thing is if you're using an IDE, you're going to get type checking like as you type, right? That's always a good thing. So that's also an option. So now let's look at a dynamically typed language like PHP. First, we write code. Then we deploy it. Then we run it. And then it's going to be like, oh, I got to compile this. Okay, it kind of compiles it on the fly, right? It parses it and then changes it to like byte code. And then it actually runs it, right? So the compilation step is kind of happening on demand. But the type checking is really happening once you've done this round trip, right? Once you've written the code, deployed it, asked to run it so that I could compile and then really run it for good. This is kind of where the type checking is going to happen. So as you can see in dynamically typed languages like PHP, the type checking happens a lot later, right? Thankfully, we do have also an IDE in PHP. Does anybody use PHP Storm? All right. So that's the nice thing about having an IDE is that, again, you can get type checking as you type. It's a really good thing. Because really, to me, having type checks at runtime is virtually useless, right? Because by that time, that code has already been deployed. And so your customers could be running into, invalid logic. But we're going to check more into that. So to me, type checking matters a lot. Passing a duck to something expecting a human is very, very, very wrong. It will hurt a system fatally. It is a programming mistake. It should be a syntax error, and it should be a compilation failure. And the thing about runtime checks, and they kind of give you increased risk, and mistakes are still going to be fatal. And they're going to be impacting the end user because you did not necessarily catch it during the development. And they're going to get, sometimes they can, not always, but sometimes they can get caught long after a deployment. So with this said, runtime checks are still better than nothing. It's something, right? It gives you a little bit more helpful error signaling, right? Instead of saying something, it'll give you a message that says you passed a duck to a function expecting a user. Now your end user will be super glad to see that, but at least if you see that in your logs, it'll inform you better than, oh, method speak not found on object, right? Something messed up. What is it? So at least it gives you more useful signaling, error signaling. So yes, PHP's type system is weak because a variable's type can change, right? I showed you the example where a variable starts out as an integer and then becomes a string, or vice versa. It is dynamic. Check that runtime. Yeah, and then so the nice thing about PHP though is it does have explicit types, but those explicit types are optional. So backward compatibility, that's good, right? Many of us do like to use types because they're a good thing. So they're only enforced optionally, basically. All right, so the evolution of PHP's type system. We used to have types on method arguments only, which were classes, interfaces, and callables. Then in PHP 7, we finally had method return types, which really made our interfaces a little bit more useful, right? Because in PHP 5, when you made an interface, it's like, okay, public function foo. Yeah, I could define an argument. Okay, what does it return? What does this method return? I don't know, right? So that was good. And it also gave us scalar types, string, boolean, integer, floats. And in PHP 7.4, we will have types to class properties. So to put things visually, you have, as of PHP 7.4, we will have, as far as type locations go, we will have types on the class or an interface, class or interface properties, class properties, class interface methods, methods, arguments, and return types. And then as far as the supported types, as of 7.4, we'll have scalars, class, and interface. Okay? And callable. Yeah, forgot to put that in there. But yeah, good catch. Yeah. Okay, so this is an example of a class using everything as of 7.4, right? So you have what we had since PHP 5, PHP 7, we could have scalars, and then return types as of PHP 7, and then as of PHP 7.4, we'll be able to have a class property. So that's an example of what it will look like. So the benefits of any type system really is to have a first-class vocabulary to signal what our intent is as we pass around variables. And then it allows us to ensure that our code does stay consistent with our intent. And obviously, it prevents us from passing a duck to a method expecting a human with more helpful messaging. That's a bit of a duplicate part. It does allow us to get rid of most annotations, right? Like we've been putting those ugly annotations on every method. I just want to get rid of all of them, right? We still have one more, throws, right? We still have throws. I want to make an RFC on that one, but I could get shot for it. So, but now we can signal our intent with like a first-class language. So, one of the challenges is, from the articles that I've read, the fact that we check types at runtime does add a little bit of overhead to the runtime engine in PHP. And that could be one reason why generics haven't progressed too much on it, right? Beyond the sheer complexity of implementing the support for it, obviously, there could be a bit of a performance overhead here. And so here's the interesting thing, though. This is kind of where static analyzers come into play, like PHP Storm, PHP Stan. Nice thing about Storm is it does it as we write code, and then Stan will do it at the CI. So what's missing, right? What are we still using comments for besides throws, tags?
Overloading.
Yeah, well, that's true. Yeah. Damn it. So we still use comments to signal that I'm going to return an array of user objects right here. So I want my IDE to know that this method right here is returning an array of users so that when I consume this method, it knows to, autocomplete on the user objects. So I'm basically using an annotation again as a crutch. So right now in PHP, we don't have a way to signal a collection of objects as a type. I could say that it returns an array collection. I could say that it returns an array, but I cannot say it returns an array of user objects, not natively at least, right? So that's why I'm using a comment to do that. So this is where we start getting into composite types, right? If you look at an array collection of user objects, it's a type, an array collection, made of another type, user, right? Array collection of user. I like to call that kind of as a composite type. So you can get to some interesting use cases, right? You have, obviously, collections. You have an array of user objects, an array collection of user objects, but you could have an object cache as well, right? An object cache made of a key, that's an integer, that could be a user ID, and then a value, that's a user object. So if you create like an object cache, you know that when you pass, you want to retrieve something from your object cache, in that get method, you must pass an integer, and you know that you will always return a user object. So there are a lot of other use cases. There are many kind of collection data structures that you see in other languages, like Java, for example, C#. You have a list of user objects. That's the closest thing to an array. It's basically an ordered collection. You could have a set. So a set does not care about order. It only cares that an object exists in a collection. You could have a queue, so you can do first in, first out. And you could have a map, so you can retrieve a user by UUID, for example. Okay, so these are all potential use cases that could be enabled by generics. So here's what it would look like on our example here. So we had this thing where we're using a comment. So we're going to make the comment go away. And we're going to make a little bit of room here. There you go. And then we're going to say : array collection angle brackets, user. That's according to the generic syntax. If you look at the RFC and the way it's implemented in other languages, that's how you would signal that your method returns an array collection of user objects. Here you go. All right, so now the question is, how do you build an array collection of user objects? So let's look at how we would do things without generics. My goal is I want to use PHP's type system to guarantee that I'm making an array collection that only has user objects or that only has duck objects. So without generics, if I do not have generics, here's how I would try to do it. I would make a user array collection which would extend array collection. I would create a new method called addUser, and in its type argument, I would explicitly say, hey, I only accept a user object to my addUser method, okay? And then behind the scenes, it would just call the parent array collections, add and pass in the user, right? The array collections add does not care about the type, right? But at least we're adding this method here that kind of acts as a gatekeeper, right? And then when you call next user on array collection, again, I am guaranteed to always get a user object, right? So here I could do, some type checking, right? To make sure that parent next is an instance of user, for example. Otherwise, I would throw an exception. That's one way that I could try to do it. Okay, so that's for a user. So now let's say I want to have a duck array collection. Again, I want to have a collection of ducks. So I'm going to create another class called duck array collection, which extends array collection and do the same thing over again, right? So now once I've done that, I can use I can say users equals new user array collection and make sure that addUser is still fine. And then when I try to add user and I pass it in new duck, then it's not going to let me do it, right? I'm going to get a runtime exception based because I'm passing the wrong type to add user. And then same thing on a duck array collection. If I try to feed it a user, it's not going to be happy, right? But obviously, to make this happen, I wrote quite a bit of code, okay? I have my array collection. I wrote a user array collection just to enforce user, and then I wrote a duck array collection just to enforce ducks, right? And now I would have to make a car array collection, and for anything that I want to enforce, I would have to make a specific array collection. It's tedious, it's repetitive, it sucks, it makes me cry a lot, right? So this is where generics can help us. If I want to do the same thing with generics, I could create a new class called generic array collection, and that's the syntax that I would use. So this little T over here is a placeholder for type. Okay, it means you can bind a type to this generic array collection, and T is going to represent the placeholder for the type you're binding to the generic array collection. Okay, and then throughout your class, this is how you reference your type, right? Which means whatever type you have bound to T, then that type will be enforced on your add method. Okay, so if you bound a user, then you can only add a user to add. Okay? And then same thing for next. It means that the next method is guaranteed to return a user object because, again, that's what you bound it to over there. Okay? So next, I'm going to show you how to do the binding, and that's how it looks like. You can go users equals new generic array collection of user, and then ducks equals new generic array collection of duck, and then right here is where you do the binding to T. Binding user as T, right here. And then with the duck, same thing. Binding duck as T. All right. So now I can have the exact same code sort of, right? But now I'm only using one class. Users equals new generic array collection of user, and then I can have all the same behavior. And then ducks equals new generic array collection of duck, and again have the same behavior here. Okay? So now that I have my generic array collection, I can make a generic array collection of user, a generic array collection of duck, generic array collection of anything. One generic class, infinite uses. Yes. All right.
Question.
Yep.
Will the RFC support nested generic typing?
I believe it will. I'm not sure.
And multiple generic types?
I don't know. Yeah. Because there are a lot of really cool things you can say. You can say where T implements an interface, for example, so you can restrict what the type is to be a subtype of something else, right? And I've seen that in the RFC.
But T can be anything.
Yeah.
It does not even have to be T within the class definition. It could be C or F.
Right. Yeah. So we use T as a convention, but yes, it can be any capital letter from what I've seen. Like I've used K and V as well for a key and value. T.
I think in Java you can even use words because you can use multiple, so you can do
Cool.
key, value, and something else.
Yeah, cool. All right. So hopefully in a possible future, we will still have those same type locations, but now we will have scalars, class, interface, callables, and generics, right? That's what I'd like to get to at some point. So when could this happen? As I alluded to, there are some challenges. It's not yet roadmap. It hasn't been voted on, so it's not yet roadmapped. From what I've heard, there are significant implementation challenges to making it happen, to support it in PHP. And like we talked about earlier, it does add a decent amount of workload at runtime, right? If you want to do this type checking at runtime, if you think about it, it could make things very interesting from a performance standpoint. So here's a possible approach, though. So I was chatting with Sarah Goldman. Do you know Sarah Goldman? Right, she's a core contributor. She's the maintainer for PHP 7.2, super sharp. So I was chatting with her at Midwest PHP, and what she mentioned was we could avoid checking generics at runtime. What we could do is we could enhance PHP to just support the syntax, and that's it. And just throw it away at compile time. And then we could rely upon static analyzers and IDEs, to do all the work, right? And you get 99% of the benefits. You could say 100% of the benefits because, again, I cannot think of an instance where checking the type at runtime has saved my butt, right? It's always when I'm working my IDE or when I'm using a static analyzer, in my CI pipeline. This is where I want to catch type errors as I am typing code, right? If PHP doesn't, can't really do it, it's fine. There are a lot of open source tools and commercial tools that can do it for us. So I think that would be a pretty decent approach. And so that's kind of what I'm trying to advocate for. So yeah, in the end, it's better to cache before the runtime. So let's look at some other languages, kind of history a little bit. Generics. In Java, they were introduced as part of J2SE 5.0 in 2004. And then in C#, they were introduced in 2005 as part of C# 2.0. But they have been around for a lot longer than that. Generic programming goes all the way back to 1973 with the ML language. I never used it, but apparently, yeah. Today, there are many languages supporting generics. You got Java, C#, F#, Ada, Eiffel, Rust, Delphi, Swift, TypeScript, VB.NET, and possibly some others. Any other language you can think of that support generics? Huh? Oh, Scala. Yeah, okay, yeah, Scala. Hack has it, yeah. Yeah.
It's like you said, it doesn't check at runtime.
Right, it does it like a compilation layer. Yeah, so Hack, that was Facebook's project, right? Where Sarah, she worked on that as well, right? Yep. Haskell, does it support generics?
Go does not.
No, Go doesn't, no. But Go is really cool, right? It does all kinds of things at compile time. At compile time of Go, if you have code that is not executed, it's not going to let you compile it. It's going to say you need to get rid of it.
Rust the same.
Rust the same? Nice, yeah. That's really cool. I'm a big fan of things like that.
Rust even catches race conditions before compile time.
Nice, yeah, cool. All right, so conclusions. The goal would be to introduce a first-class vocabulary for composite types. We could reduce code duplication to enforce type correctness. We could remove comments to signal our intent. No more comments. Yeah, except for throws. Next, RFC. Check exceptions. Okay, so, and the idea is to ship systems that fail less in production. That's always a better thing, right? And I would be in favor, as many of us here, to promote type checking before the runtime, definitely in real time with IDEs. At the CI pipeline with something like PHP Stan or any other static analyzer. And to let static analyzers to carry the burden of generics, such that PHP can gleefully support but ignore the generic syntax. That's all I had. Thank you. Here are the slides.